Hello everyone, so welcome to my YouTube channel. So guys, we are going to start with the chapter number 3. Chapter number 3, classification of elements and periodicity in properties for the CET crash course. Okay, so let's see the time. The time is 4:30 and it's 4:30 a.m. in the morning, and we are going to do the recording for this. Okay guys, see, before this you have to know that the atomic number of few elements almost till 30, atomic number till 30. Okay, the name of the elements for atomic number till 30, it will be helpful for you to finding electronegativity, ionization, enthalpy, that's trend. Okay, sure. So guys, before starting, where we will get this video, you have to go to my channel, go to the playlist. In playlist you will see the CET course. In that you will get this video. Okay, so guys, in today's video, like, see, I had uploaded the chapter 1, some basic concept of chemistry. So in that it is a part 1, part 2. Part 1 is synopsis, part 2 is the PYQs and hot questions. Same if you'll come for the chapter number 2, structure of atom. Same guys, I had uploaded in part 1, part 2. Part 1 is a synopsis like this, where we'll explain all the concept with short tricks and all. Part 1 is a synopsis, and part 2 will be the PYQs plus hot questions. But in this chapter 3, classification of elements and periodicity in properties, we don't have part 1, we don't have part 2. One only, in which you will get whole synopsis also, and then PYQs plus hot questions also. We have a 43 total. PYQs plus hot questions, we have a 43. Okay, so let's start. Okay, classification of elements in periodicity, classification of elements and periodicity in properties. Chalo bhaiya, chalo karenge start guys. So first is what? Genesis of periodic table. So genesis of periodic table, first we will see the Dobrunier's law of trades. Now you see, law of trades, trade indicates that when we will take 3 elements, trades means 3 elements. Okay, so in the trade of element means in a 3. Okay, trade means we'll take a 3. Okay, so in the trade of elements, the atomic weight of middle element is the average, or average, what we will say? We will say arithmetic mean. It's not aim. Okay. Okay. So Dobrunier law of trades, what it says? In the trade of elements, the atomic weight of middle element is the average or arithmetic mean of what? Atomic weight of first and third element. Okay, so what the Dobrunier's law of trades said, that we have to take the 3 elements. We have to take 3 elements. 1, 2, 3 elements. So the average, if you'll see the average, see, atomic weight or atomic mass, both are same in this what? Arey oh bhaiya, bolo re pyare. In chemistry, both atomic mass and atomic weight are same. The reason behind, in chemistry we don't see the gravitation, so mass and weight are same. But in physics, mass and weight are different because their gravitation will come. So dekho re bhaiya. So in the trade, so what we will see in the Dobrunier's law of trades, we will take the 3 elements in which the atomic mass of middle element is the average of atomic mass of first and third element. We know this. So suppose elements is lithium, sodium, potassium, 3 elements. Atomic mass of lithium is 7, sodium is 23, potassium is 39. So what we will see? Atomic mass of middle element, middle is sodium, so atomic mass of sodium is what? Average of atomic mass of first and third element. The atomic mass of first is 7 and atomic mass of third is 39. So average means what? Bolo re bhaiya, we know average, right? Average means number of elements divided by, sorry, sum of elements divided by total number of elements. We'll get the average. So sum of elements, the atomic mass is what? 7 plus 39 divided by how many elements are there? 1, 1, 2. So number of elements are 2. So divided by 2. So you will get 39 plus 7 is 46 by 2, which is 23. Yes, it is same. So yes, this is the Dobrunier's law of trades said. After that, Dobrunier's Newland's law of octave came. So I see Dobnier's law of trains. He had given this much of the concept, but it was not applicable for higher elements. Okay, so what will happen? Dobnier's law of trains, moe moe, but it happened moe moe, but still we have to study. Bakwas. Then Newland's law of octave came. Newland's like, hey, Dobnier's law of trades don't know anything. Chattu Muttu has given ashte. I will come. Then Newland's law of octave came. So Newland's law of octave, we know guys what it says. Elements are arranged in increasing order of atomic mass. Guys, see Dobnier's also, it took the element based upon the atomic mass. Okay, so Newland's law of octave is also based upon atomic mass. So elements are arranged in increasing order of atomic weight. Atomic weight or mass both are same. So guys, here what they say, Newland's law of octave is elements are arranged in increasing order of atomic weight. So what he will see? He will see the properties of every 8th element shows the similar properties with first element. Okay, so this much you have to keep in your mind. The properties of every 8th element. We'll see first element, second element, third element, fourth, fifth, sixth, seventh, 8th element. Every 8th element, it will show the similar property to the first element. Okay, but again Newland's law of octave, it got limits up to calcium. That's it. Calcium is atomic mass 40, because A indicates the atomic mass, so it limits up to calcium. So Newland's law of octave follows the musical notes. Sometimes they can ask in the examination which of the law follows the musical notes. Newland's law of octave. Okay, right, the musical notes is what? Sa re ga ma pa dha ni sa sa. Again it will start, every 8th element will follow the same properties of first element. So it follows the musical notes. In exam they won't ask after sa re ga ma dash what will come. Don't start with sa re ga ma pa dha ni, sa re ga ma pa dha ni. You will, by hearting that and going for the examination hall, Lata Mangeshkar and all will come. Okay. Now Newland's law of octave got failed. See, the thing is what, now if you will get failed, you will call as failure. No one will going to respect you, no one is going to focus on you. But chemistry is not like that. Every scientist came, they are discovering chuttu sa thing, and later on we'll see that, oh, these scientists have a drawback, so this scientist got failed. So failed means भैया remove ना, failed हो चुका है, why we have to see? But no, chemistry is like the failed ना, study that also, study their observation, their conclusion, their drawbacks. दिल के अरमासूमों में बह गए. Okay, first Dobnier's law of trade, next Newland's law of octave. Newland's law of octave also got failed. So next came Mendeleev's periodic table. Bhaiya, see, till now they had not asked, but if they will ask who is the father of the periodic table, we'll say Mendeleev. Because Mendeleev almost it gave the 80% of the periodic table Mendeleev have made. Okay, so Mendeleev periodic table. The Mendeleev periodic table, what it says, elements are arranged such that the properties of elements are periodic function of their atomic weight, means again atomic mass. So it also based upon the atomic mass. So what is the drawback? Place of hydrogen is not fixed in the periodic table. Mendeleev also khatam. Drawback. Now next came modern periodic table. Guys, modern periodic table is also called as long form of periodic table. So if in the examination they will say long form of periodic table is nothing but modern periodic table. So modern periodic table is given by Henry Moseley Baba. Henry Baba ki jai ho. Modern periodic table is given by Henry Moseley. See, the main concept why Henry Moseley's, that you know, this modern periodic table got clicked, the only reason behind it, see here what it says. The first point, physical and chemical properties of elements are the periodic function of their atomic number. अरे ओ प्यारे देखो ना रे भैया, Dobnier's law, Newland's law, then Mendeleev, all these were focusing on what? Atomic weight, atomic mass. Because of that they cannot able to succeed. Why the modern periodic table? The Henry Baba. So that's why you'll say Henry Baba ki jai ho. So why the Henry Baba got succeed? The reason behind is Henry Baba used the atomic number. He didn't use atomic mass. Henry used atomic number. Teri pyari pyari do akhiyan. Okay, to focus. So the main reason it succeed is use the atomic number in place of atomic weight. So periodic function is due to repetition of similar outer electronic configuration after certain regular interval. We know, guys, noble gas, again noble gas, noble gas, noble gas. What is happening? Periodic function, repetition of similar outer electronic configuration. If you take out the halogen group, fluorine, chlorine, bromine, iodine, so what is happening? Again they are following the same electronic configuration. Noble gas, again same electronic configuration. Group number 1 S1 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 outer electronic configuration. Group number 2 S2 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 outer electronic configuration. So that's why they say the similar outer electronic configuration after certain regular interval. So what is the interval, guys? If you start from S1, you will go to the whole period, again you will come to S1, again whole period, again S1. So what is happening? After certain regular interval of time, you are coming to S1 S1 S1, which is having outer electronic configuration of 1 1 1. Again you will go for S2. So after again you will go the period, and then again you will come to the S2. Again you will move the whole period, again you will come to the S2. So what is happening? After again certain regular interval, you are coming to the same electronic configuration, that is S2 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 S2, like that. So we know that 18 vertical column, that is called group, 7 horizontal rows, that is called period. Now we'll see the blocks. Easy peasy, guys. See, element of group 1 and group 2 is S block, right? We know. Then group 13, 14, 15, 16, 17, 18 is P block. Elements of group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is D block. Correct? Then F block is what? F block elements comprises 2 horizontal rows. 2 horizontal rows, right? Placed at bottom of the periodic table. If you see the periodic table, see this they are talking about this bottom of the periodic table. This is the S block. Group 1, group 2 is the S block. This whole is the S block. Then group 13 to group 18, this whole is a P block. Then group 3 to group 12, this whole is a D block. Just this lanthanoid and actinoids, which is the F block, which is coming here. So it says that 2 horizontal row. Sorry guys, 2 horizontal rows placed at bottom of the periodic table. One is lanthanoids, another is actinoids. Okay. Now elements of group 1 is called alkali metal. We know, guys, we know that this is the group 1. All the elements of group 1 is called as alkali metal. Elements of group 2 is called as alkaline earth metal. Alkaline earth metal. Elements of group 15. Group 15 is this nitrogen group, right? Group 15 is what? Nitrogen group. The elements of group 15 is nitrogen, means nictogen. Start with N. N indicates nitrogen, nictogen. Elements of group 16. Elements of group 16. This is a group 16 means oxygen. Group 16 means oxygen. So chalcogens. Elements of group 17, halogens. Elements of group 18, noble gas or aerogens. See, S and P block elements are called as representative elements because it will represent first S block, then P block, then D, F. So S and P block are called representative elements. The S block elements and P block elements, all the elements are called as representative elements. So then what the D block element called as? Transition element. What the F block element called as? Inner transition element. Then we get to know which block elements is called as what. Now guys, we know in the first period we have a 2 element. First period means this is the first period. We have a 2 elements. In second and third period we show the same. We have a 8 elements. Fourth and fifth period we show the same. We have 18 elements. Sixth and seventh period we show the same. We have 32 elements. Okay. Now we'll come for the nomenclature of elements. Nomenclature of element, guys, this is important. So this is the digit. I know you also know how to write this. So this is the digit, its name and abbreviations. So if it is a 0, we'll call it as nil. 1, un, 2 by, 3 try, 4 quad, 5 pent, 6 hex, 7 hept, 8 oct, 9 in. This is the thing. So for writing the IUPAC name, guys, see, this is the nomenclature. This is the nomenclature only applicable from 101 to 118. That's it. Before 101, it's not applicable. 101 to 118 is applicable. You can do applicable for 119, 120 also. Okay. So IUPAC naming, this IUPAC naming will do from 101 to 118. So what we will do, from 101 to 118, whatever the name will come, at the last we have to put EM, IUM, EM. Okay. So this is a trick I will tell you. This is a trick I will tell you guys. So before that, first observe here. So see, this is the atomic number. This is the IUPAC name. Based upon that atomic number, how we will write, then its symbol. And the mostly important thing is this IUPAC nomenclature, the real name. Okay, see, this is the IUPAC name. This is the IUPAC nomenclature real name. Now guys, see, if I will take 101, so 101 means what? 1 is un, 0 is nil, again 1 is un, nil, un. At the last, what I have to put? EM. Okay, so 101 name is nil, unium. So symbol means for 1 it is U, for n, sorry, 0 it is n, again for 1 it is U, U and U symbol. This I will tell you guys, this I will tell you. Now suppose same 105. 105 means 1 is what? Un, 0 means what? Nil, 5 means what? Pent, nil pent, and the last I have to write EM. Nil pentium. Same 112. Anything you can take, guys. Anything. 112. So 1 means un. Again 1 means un. 2 means by. And at the last I will write EM. Same, suppose if I will take 115. So un. Again 1 is un. 5 is pent. And the last we will put IM. IUM. EM. Pentium. This is easy, guys, because you know this, you know this, so you can able to write. Okay. Now very important thing in the examination, guys, many times they had given this atomic number, they ask the real name for the IUPAC nomenclature, or they will give this IUPAC nomenclature, we have to write the real name. That is very important. Or sometimes they will give the real name, you have to write the atomic number, means you have to tick the correct atomic number. So guys, see, very important thing, from 101 to till 118, it's not easy to remember the whole name. So what I'm going to do, I'm giving you the trick. If you remember this much of trick, guys, this whole the things will get over easy peasy. So guys, see here, because see, atomic number 101 to 118, this IUPAC nomenclature is very easy, right? Because you know the things, what you will say for these digits, according to that you will write. Suppose 113, 113. So 1 we will say un, again 1 means un, 3 means try, try, and then at the last EM, try EM. That's it. So this is the easy way to write. Main thing is what? You have a complication here. So for this I will tell you the trick, because in the examination you will be having the options, so you can tick it. See here, the trick is, guys, this you have to remember the 3 points, 1 point, 2 point, 3 points. So here what you have to do, you have to remember the 3 points. So see, first point is what? Mendeleev को मिला नोबेल इन लॉरेंस. फर्स्ट पॉइंट इज व्हाट? चलो बोलो, अरे बोलो रे भैया, मेरे साथ साथ बोलो. मेंडेलीव को मिला नोबेल इन लॉरेंस, फर्स्ट. सेकेंड पॉइंट इज रदरफोर्ड डूबे सी में, डूबे मीन्स सिंक, तो रदरफोर्ड डूबे सी में, बोर हंस मत डर से रोए कॉपर. फर्स्ट इज व्हाट? मेंडेलीव, चलो बोलो रे भैया, बोलो रे प्यारे. मेंडेलीव को मिला नोबेल इन लॉरेंस, मेंडेलीव को मिला नोबेल प्राइज, बोला नोबेल इन लॉरेंस. सेकेंड व्हाट हैपेंड? रदरफोर्ड डूबे सी में, बोर हंस मत, डर से रोए कोपर. What is third? Neho flee Moscow to leave Ten-Ogen. Ten-Ogen is a place name in Moscow. Neho flee Moscow to leave Ten-Ogen. Okay. Now guys understand. Whatever I underline, these are the name. So Mendeleev को मिला Nobel. Mendeleev, Nobel, Lawrence. These are the elements name. So 101. Mendeleev is 101. So guys see what is the name of 101? Mendeleevium. So don't remember the full name. If suppose they will give the atomic number 103, you have to write the name. 103 means what? Mendeleev, Nobel, Lawrence. Lawrence 103 belongs to Lawrence. So you will see in the option. Lawrence is what? See, Lawrencium. Means you will take this option, Lawrencium. That's it. Okay. So 101 is Mendeleev. See, Mendeleevium. 102 is Nobel. See, Nobelium. 103 is Lawrence. Lawrencium. 104 is Rutherford. 5 is Dubé. See, 105 is Dubé means see, Dubnium. So you will get to know okay, Dubnium. So like that you can identify and you can tick the option in place of by hurting the whole name. Okay, see, 101 Mendeleev, 102 is Nobel, 103 is Lawrence, 104 is Rutherford, 105 is Dubé, 106 is C. C means C, 106. 106 means C Borgium. So what you will see, you will not remember this whole name, just you will see the starting with C Borgium. So see in the examination, suppose they will give Nilhexium. So you have to write its real IUPAC name. Then you will see Un means 1, Nil means 0, Hex means 6. 106. 106 means you will see C. C, so you will see in the option where is C. Mendeleev, Nobel, Lawrence, and therefore like that they will give C. So tick that C Borgium. That is the correct answer. Okay, no need of remembering this whole name. 107 related to Bohr. 108 is Hus. So see 108 Hus means 108 Hus means this Husium. 109 is Mat. Mat means see Mathnerium. So this 110 is Dur. 111 is Roy. 112 is Copper. 113 Niho. See 113 is Niho. So 113 means see Nihonium. So Niho. 114 is Flea. Flea means see Flerovium. So from flea. So like this you will understand that which element. So you can tick in the option or you can match the following. Okay. 114 is Flea. 115 Moscow. 116 Leave. 117 10. 118 Organ. So this is the easy trick to remember the name, the real name for the IUPAC nomenclature, the real name, because this is very easy to remember, right? And this is the difficult to remember, so you can remember by using this trick. What is the trick? Arey bolo re bhaiya. First is Mendeleev ko mila Nobel in Lawrence. Second, Rutherford डूबे सी में, बोर हंस मत, डर से रोए कूपर. Third is what? Third is Niho flew Moscow. So Niho flew Moscow to leave Ten-Ogen. That's it. अरे भैया समझ लेना guys, this is very very important. Now we'll come to the periodic properties. Periodic property, the first properties we will see is atomic radius. We know guys what is atomic radius? Distance between the center of the nucleus to outermost shell. So guys, atomic radius we have we have a 4 type of atomic radius here. Okay, first is covalent radius. We know the covalent radius when these two like overlap each other, one atom another atom, when they overlap each other, this is the overlapping part. When they overlap each other, that is the covalent radius. Next is what? Metallic radius, when they are not overlapping, when they are just touching the boundary, that is metallic radius. Van der Waals radius, both are very far. Okay, ionic radius, guys, ionic radius very easy. The distance from the ion's nucleus to its outermost electron. Okay, that's it. Suppose this is the ion, this is the outermost electron cloud. So this is the ionic radius. That's it. The radius of the ion is ionic radius. Okay. So covalent radius means overlapping. You can say they are in relationship, overlapping each other. mutual understanding, their relationship. Metallic radius, just they are touching the boundary. They are in situationship. Just they know each other. Situationship. Van der Waals radius, see, they are very far. Breakup happen. Okay. So covalent radius definition is one half of the distance between the nuclei of two identical atoms joined by a single covalent bond. So covalent radius for covalent bond, used for non-metal. This is important. Covalent radius for covalent bond, and it is used only for non-metals. And covalent radius means the atoms will be overlapping each other. Now metallic radius. Metallic radius is what? Half the internuclear distance between two adjacent identical metal atoms in a crystal metallic lattice. So metallic radius is in metallic lattice. Okay. So here guys, it is used for metals. So they are just touching the circumference or the boundary. Now van der Waals radius means the radius of an imaginary hard sphere. Why imaginary hard sphere? Because they are not very close to each other. They are far apart from each other. So radius of an imaginary hard sphere representing the minimum distance it can approach another atom before intermolecular repulsive force take over. So guys, see what will happen. Why they are not close to each other? The reason behind is they have a intermolecular repulsive force. So repulsive force are their intermolecular repulsive force. So that's why they will not attract each other. They will repel each other. So every time they have a difference, means sorry, not difference. They have a distance between them. Okay. So van der Waals radius means we have a distance between them. Ionic radius is done. Now next, see. Done about the radius, we understand. Now ionization enthalpy. Guys, we know the basic definition of ionization enthalpy means the energy required to remove an electron from the outermost shell. So whatever the outermost shell electron is present, the energy required to remove the electron from outermost shell of an isolated gaseous atom in its ground state. You see, we will remove the outer electron from the outermost shell, that is nothing but in a ground state. So that's why it will become very easy to remove. Okay. So see, definition guys, basic definition you know, right? And examination very rare they will ask the basic definition. So basic definition just for understanding. What is the ionization enthalpy? Ionization enthalpy is nothing but the energy required to remove an electron from outermost shell of an isolated gaseous atom in its ground state. So see, these are the relation, not yours. Okay, these are the relations between this. So relation between ionization enthalpy and size of atom. So ionization enthalpy is inversely proportional to size of atom. Ionization enthalpy is directly proportional to effective nuclear charge. Ionization enthalpy is inversely proportional to screening effect, because 1 by means inversely proportional. This is directly proportional. Now see, this is the order. Suppose if we are finding first ionization, this is what? First ionization enthalpy, second ionization enthalpy, third ionization enthalpy. So guys, see, first, second, third means what? Suppose you have a neutral atom. Suppose you have a neutral atom. So from this atom, I will remove an electron. So removing an electron means what? Plus, right? Removing means plus, adding means minus. Cations, correct? Plus means cation, minus means anion. So guys, see what will happen. This is a neutral element. From here I will remove one electron. So from here, if I will remove one electron, it will become N plus. So this step, removing one first electron from the normal element, that is called ionization enthalpy first step. Now we got N plus. From this element, again I am going to remove one more electron. So N plus it was, and one more electron I will remove, it will become N2 plus. So this step is called ionization enthalpy 2. Again from this ion, what I will do, I will remove one more electron. So if you remove one more electron from N2 plus, it will become N3 plus, and this step is called third ionization enthalpy. So guys, what is happening, understand the thing. If we have a bigger atom, so what I'm doing in ionization enthalpy, I'm removing one electron. So as you will remove the electron, what will happen? The size of atom will reduce, correct? If you're removing the electron, so what is happening? Number of electron is reducing. If number of electron will reduce, means what will happen? Number of shell will reduce. So if number of shell will reduce, means size will decrease. So that's why if the size is bigger, so what is happening guys, from nucleus to outermost shell, the force of attraction is very less because size is bigger, shielding effect. So for bigger size, what is happening? The force of attraction between the nucleus and the outermost electron is very less because of shielding effect. So what is happening? It is very easy to remove the electron. But as you keep on removing the electron, size is reducing. If size is reducing, means the outermost electron is coming closer to the nucleus. Then the force of attraction from the nucleus to outermost electron will increase. So if the force of attraction is more, then we have to use higher energy required to remove the electron. So that's why as you are removing the electron, the size of the atom is decreasing. If size of the atom is decreasing, means outermost electron is reaching near to the nucleus. So what is happening that time? The force of attraction will increase. The force of attraction will increase means we have to use higher energy to remove the electron. So that's why ionization enthalpy third process, means the bigger process, is having the more ionization enthalpy, then second, then first. First for ionization enthalpy for the first is very less. Okay. Now guys, in the examination, understand one thing. If it is half filled orbitals means like D5, because D total is what, 10. Half filled orbital or completely filled orbital. For P means half filled orbital or completely filled orbital. For F means half filled orbitals or completely filled orbitals. Guys, half filled or completely filled orbitals, they have higher ionization enthalpy. The reason behind, if it is completely filled, we know if it is completely filled means very difficult to remove the electron from that. So we have to use the high ionization enthalpy. And then half filled, guys, half filled also is a very difficult to remove. Okay, so half filled orbitals and completely filled orbitals, the removal of electron is very difficult. So in that case, ionization enthalpy will be higher. Suppose they will give any two elements. One element's electronic configuration is P3. One element's electronic configuration is P5. Okay. So if we have to remove one electron, means first ionization enthalpy if I have to do, whose ionization enthalpy will be more? अरे भैया बोलो रे प्यारे, देखो guys. So guys, this is a P. P means what? Maximum is 6. So guys, see, this is a half filled. But this is not a half filled, this is a normal. So guys, half filled or completely filled, they have a higher ionization enthalpy. So first ionization enthalpy means this P3 will be, we require the more energy to remove the electron from half filled orbitals. But P5 means it is not a half filled, it is not a completely filled. So the ionization enthalpy, the energy required to remove the electron is very less as compared to P3. So what will happen guys? P3 or P5 is the suppose element A and B. So what is happening? Ionization enthalpy for A is more as compared to B. Okay, understand? So as you are removing the electron, ionization enthalpy increases, because as you will remove the electron, the shell is reaching near to the nucleus. So as it will close to the nucleus, the force of attraction will be higher. So we require the higher amount of energy to remove the electron. Okay, understand? Yes sir, very good. And we have to understand this thing guys. Half filled and completely filled orbit means half filled and completely filled having the more higher ionization energy, because half filled and completely filled, it requires a higher or larger amount of energy to remove the electron as compared to others which is not half filled or which is not completely filled. Okay, fine. Now electron gain enthalpy or electron affinity. So what is this? The amount of energy released when an electron is added to the outermost orbit of an isolated gaseous atom. Okay. So electron gain enthalpy, electron affinity, what will happen guys? Here energy is releasing. When energy is releasing? When an electron is added to the outermost orbital. Okay. So it's same as compared to this. See, ionization enthalpy is inversely proportional to 1 by size of atom. Same. EGE means electron gain enthalpy. Electron gain enthalpy is also inversely proportional to 1 by size of atom. Ionization enthalpy is directly proportional to effective nuclear charge. This electron gain enthalpy is also directly proportional to effective nuclear charge. Ionization enthalpy is inversely proportional to screening effect. Same, electron gain enthalpy is also inversely proportional to screening effect. Both is having the same trend. Okay. Next is electronegativity. Electronegativity, guys, see, first is what? Ionization enthalpy. Ionization enthalpy, guys, we require the energy to remove the electron. We are removing the electron. In electron gain enthalpy, what is happening? Amount of energy released. When electron is added, we are adding the electron. Okay. But in electron gain enthalpy, electronegativity, what will happen in electronegativity? It will not remove, it will not add. It will just attract the electron, which is having more higher electronegative element. It will just attract the electron towards itself. It will not remove the electron. It will not add the electron. It will just attract the electron towards itself. Means, just as example, if I will take suppose HCl, I will take HCl, hydrogen and chlorine. So hydrogen and chlorine are connected with single bond. So hydrogen is having one electron, chlorine is having one electron. Correct? So in hydrogen and chlorine, which is more electronegative? We know chlorine is more electronegative, Cl minus. So chlorine is more electronegative, means what will happen? The tendency of an atom in a compound to attract a pair of bonded electron towards itself. It will just attract. So what it will do? From this side of hydrogen, what it will happen? This hydrogen, chlorine. From here, the electron will, this electron will remain here. So from here, the electron will attract it towards chlorine. So this indicates that chlorine is more electronegative as compared to hydrogen. So in electronegative, what will happen, guys? It just attract a pair of bonded electron towards itself. That's it. So most electronegative element is F, means fluorine. Fluorine, that value is 4.0. This is important, guys. In the examination they can ask. And least electronegative element is francium. Its value is 0.7. Okay. Now we'll see the diagonal relationship. We are not seeing your relationship, but we are seeing diagonal relationship. Okay. Diagonal relationship, very important, guys. Diagonal relationship is between second period and third period. So what will happen in diagonal relationship? Certain element of second period shows similarity with their diagonal element in third period. Means certain element of second period, it will show the similar physical and chemical properties with their diagonal element in third period. Why? The reason. Many times in the examination they can ask the reason. Due to identical ionic radii and polarizing power. This is important. Due to identical ionic radii and polarizing power. Okay, understand what happens? Certain element of second period will show the similar physical and chemical properties with their diagonal element which is present in third period, because period 2 down is third period. Okay, because we know this here, guys. See, I have told you here, first period will be separate, second period and third period will show the similar physical and chemical properties. Here fourth period and fifth period will show the similar, sixth and seventh will show the similar. Okay. See, elements of second period, only the elements of second period are known as bridge elements, because they will form the bridge with the third period elements. See, period 2, period 3, these are the elements which show the diagonal relationship. Lithium, beryllium, boron, carbon, nitrogen. Here it is sodium, magnesium, aluminium, silicon, phosphorus. So guys, see here, sodium and nitrogen will not form the what diagonal relationship with anyone. Lithium, that is a period number 2 element, it form a diagonal relationship with period number 3 element, that is magnesium. Because see, in the examination they can ask boron is a second period element, with which element it form a diagonal relationship. So it form element with period number 3, that is nothing but silicon. Okay, yes sir. Now guys, this is the periodic trends guys. Periodic trends, these are the periodic properties down the group along the period. Okay guys, very important thing, if you remember the periodic properties for down the group, along the group will become ulta. Just imagine as example, atomic radius down the group increases, then along the period ulta decreases. Same ionization enthalpy down the period decreases, so along the period ulta means it will increase. Okay, so if you remember for the down the group, because the many student what they will do now, they will get confused, like they will start by hitting both down the group along the period, down the group along the period. It's not easy. So remember for down the group, so what is happening for down the group, it will be ulta for along the period. If down the group it's increasing, along the period it will be decreasing, or down the group if it's decreasing, then along the period it will be increasing. You can just check it out. Okay, now guys, we have a 12 periodic properties. The name of the periodic properties total we have is 12. So by hurting all the 12 is not that much easy. So guys, what I will tell you, just by heart this 5: atomic radius, metallic nature, electropositivity, basic nature, reducing nature. So what will happen, these 5, what I said guys, just remember for down the group, don't remember for along the period, because whatever the down the group, along the period will become ulta. Okay, so guys, just remember these 5 periodic properties for down the group. The reason behind is रुको जरा सब्र करो. The reason behind is, see the 5: atomic radius, metallic nature, electropositivity, basic nature, reducing nature. You have to remember for these 5. So these all 5 down the period is increasing. These all 5 is what is happening, down the group is increasing. Sorry, down the period I said, down the group it is increasing. Okay, so see, atomic radius, metallic nature, electropositivity, basic nature, reducing nature, these 5 down the group, these 5 are increasing down the group, except these 5 guys, all the other periodic properties down the group it is decreasing. So that's why just check it out. You have to remember for down the group, whatever is the down the group, along the period it will be ulta. Okay, first thing. Second thing is, just remember for 5 name down the group, the 5 name down the group is always increasing. Like atomic radius down the group increasing, metallic nature down the group increasing, electropositivity down the group increasing, basic nature down the group increasing, reducing nature down the group increasing. So these 5 periodic properties down the group it's increasing. Remaining these 5 properties, remaining these 5 periodic properties, all other periodic properties down the group it's decreasing. Khatam. So if you will remember, just these are the periodic properties down the group is increasing. So we know except these 5 periodic properties, whatever the other periodic properties will come down the group, directly you will say it is decreasing, because we know these 5 will be increasing down the group. So whatever the other will come, you will say that it is decreasing down the group. Khatam. If it is decreasing down the group means increasing along the period. If it is increasing down the group means decreasing along the period. That's it. This is the synopsis guys. Now we'll come for the PYQs and hot questions. See, synopsis done in almost 26 minutes. That's it. Before synopsis used to complete 1 hour. There's some basic concept of chemistry and structure of atom. This is nothing. So it done in 26-27 minutes. So that's why again the PYQs and hot questions will get over in another 30 minutes. So in 1 hour this whole chapter will get over. So that's why I didn't make the 2 part for this chapter. Okay, let's start. PYQs plus hot question guys. In traits means 3 element. Okay, and who has given the traits? Only one scientist given the trait, that is Drobnier. In traits, the atomic weight of middle element is the average of atomic weight of first and third element belongs to which law? Traits means only one law, Drobnier's law of traits. Newland's law of octet limited up to which element? calcium. Demerits of Mendeleev's periodic table, place of hydrogen is not fixed. In Mendeleev's periodic table, elements are arranged such that the properties of elements are periodic function of. Guys, we know Dobnier's, in Newlands and in Mendeleev that elements are arranged such that the periodic properties are periodic elements are arranged such that the properties of elements are periodic function of atomic weight or atomic mass. This thing will happen in Dobnier's, Newlands and Mendeleev. But when you will come for the modern periodic table, same thing, the properties of elements are periodic function of their atomic number. Yes guys, yes. See, who revolutionized atomic science by proving that atomic number, not atomic weight, defines the properties of element. Bolo re pyare, atomic weight is Dobnier has taken, Newlands had taken, Mendeleev had taken the atomic weight or atomic mass. But who proved that atomic number, not atomic weight? Yes, only one who proved that atomic number is a Henry Moseley, which we will follow in, yes, modern periodic table. So Henry Moseley means who discovered the modern periodic table. He discovered the modern periodic table based upon the atomic number. So that's why its modern periodic table is successful. In modern periodic table, how many groups and periods are present? 18 groups, 7 periods. Ashte. See, groups present in D block element. What are the groups? Group 3rd to 12th. Elements of group 2 is also called as alkaline earth metal. Which group is called chalcogens? Elements of group 16. F block element is also called as, we know that it is inner transition elements. Now see, IUPAC name of elements with atomic number 107 and 119. So bhaiya, are oh pyare. See, in the examination again we have to see the option. What we will see? Yes guys, yes, we have to see the options. Based upon the option we have to write the IUPAC nomenclature. Okay, either that real one or the only IUPAC nomenclature. The option is like this. So we'll write 107 means what? 1 is un, 0 is nil, 7 is sept, and the last is ium. Un, nil, septium. Now 119. See, in the examination they'll ask for 119, 120, 121, 122, 23, 124, 125, like that. Sometime in the examination they will ask. Don't think that, oh, question is wrong, we studied only till 118, but this is 119, or they will give 122, you will say that question is wrong. Marenge padappada guys ekdam. Question is not wrong. From 101 onwards we will use this type of IUPAC naming. So 119 means 1 is un, 1 is un, 9 is in, ium. That's it. Suppose in the examination they ask 122 also. So don't say, hey, 122 we studied till 118 now. 122 is wrong. Yes, 1 marks grace. Woohoo! They will not give the grace marks. Okay. So from 101, please use these type of thing to write. 122 bolo re pyare. Are pyare bolo re. 1 means un, 2 means by, again 2 is by. So un, by at the last ium. Okay. See, this type of questions what I was saying you, they are given the atomic number, you have to match with IUPAC official name. See, 103 is what? Mendeleev Comilla Nobel in Lawrence. So 103 is Lawrence, related to Lawrence. This is Dur, this is Bohr, Lawrencium, this is liver. So 103 belongs to Lawrence, like that. 110, it's like a Dur se roe copper. Dur. So see the Dur, liver, law, Bohr, Dur. So 110 is Dur. Like that you can match. In place of remembering this big name, just remember that. Mendeleev. So 101 is related to Mendeleev. Mendeleev Comilla Nobel. 102 is related to Nobel. Lawrence. So 103 related to Nobel. Rutherford Dubé C में. So 104 related to Rutherford, 105 related to Dubé, 106 related to C. Dubé C में. Okay, like that. So 107 means Bohr Hasmat. So 107 related to Bohr. Okay, 116. 116 like फ्लू सी 116 is what कहाँ गया भैया हाँ सी नीहो फ्लू मॉस्को टू लीव related to leave yeah related to leave with this livermorium. So this is the correct answer. So like this guys, you have to remember that trick and then the number, because in the examination they will give the atomic number, you have to write its IUPAC official name, means match the following, that's it. Covalent radius is used for non-metals. How ionization enthalpy is related to screening effect? Ionization enthalpy is inversely proportional to screening effect. How whatever the ionization enthalpy, same electron gain enthalpy or electron affinity is also following the trend. Amount of energy released. Okay, so amount of energy, what is happening? Releasing. Amount of energy released when an electron is added to the outermost orbit of an isolated gaseous atom. Yes, electron affinity. Name the least electronegative element and its value. Francium is the least, its value is 0.7. Diagonal relationship is between element of which period? So second period and third period diagonal relationship, correct? Yes sir. Element of second period in diagonal relationship are known as bridge elements. What happens to non-metallic nature if we go down the group? So guys, see, down the group we have to learn only for down the group. In the examination they will ask along the period, means from down the group we will change along the period. Okay, see, down the group only 5 thing is positive. Atomic radius, see this 5. Oh, wait. Down the group is atomic radius, metallic, electropositivity, basic nature, reducing nature. So what we have to find? We have to find non-metallic nature. So non-metallic nature will not come under that 5. Non-metallic nature is not under this 5. So if non-metallic nature is not under this 5, then down the group it is decreasing. So along the period it will be increasing. So non-metallic nature decreasing, down the group along the period it will be increasing. Right? Easy hai guys, easy peasy, chuttu muttu sa. Okay. Now next is, what happens to electropositivity when we move? Okay, when we move along the period. See guys, now along the period we have to tell about along the period, but we studied only for the down the group. So whatever the down the group will come, it will do ulta, will get the along the period. So electropositivity, guys, see, electropositivity we know, yes, electropositivity will come under this 5 name. So if electropositivity is coming under this 5 name, means electropositive down the group is increasing. They are asking along the period, so it will be decreasing. Okay, yes sir. Which group contains maximum number of gaseous element? Guys, we know which group is consisting. Bolo re bhaiya. Are very easy guys. See, which group consists maximum number of gaseous atom? Noble gas, group number 18. So group number 18 is also called as noble gas, group 18, or zero group. Zero group means we don't have any valence electron, all are completely filled, so that's why zero group. Total number of gaseous element in periodic table is very important. We have 11 elements. What are the elements? First of all, we'll write all the name of the elements of noble gas, because noble gas is a gaseous element. Helium, neon, argon, krypton, xenon, radon. Okay, noble gas, because these are the noble gas which is a gaseous, because noble gas, the gas form. Then hydrogen is a gas, nitrogen is a gas, oxygen is a gas, right? Hydrogen is a gas, nitrogen gas, oxygen gas, and then fluorine and chlorine is also a gas. So total of 11 elements. Name, remember the name. Which of the following does not form trade? Does not form trade means the what jaldi bolo. The mass, atomic weight of middle element is means what I will say, atomic weight of middle element equals to atomic weight of average of atomic sorry guys. Okay, which of the following does not form trades? So does not form trades, we know the condition for forming the trade is what? Are bhaiya jaldi bolo re pyare. See, for what you can say, the rules for forming for trade is what? Atomic weight of middle element is the average of atomic weight of first and third element. So guys, they had given the element, they had given the atomic mass. We have to check it out. First we will take the triads is chlorine, bromine, iodine. Where it is? Yes, chlorine, bromine, iodine. Just check it out. Bromine is what? 80. So atomic mass of middle element equals to average of atomic mass of first and third. The 127 plus 35, 127, 137, 47, 57, 162.5. Average means divided by 2. 162 divided by 5 means, guys, you are getting around 81 point something. No, we want 80. It's not possible. Okay. Okay, wait. Then chlorine, potassium, calcium. So guys, see, mass of chlorine is what? 39. Okay, mass of, see, fine, it is, which of the following does not form trade? So this is 80 and this side we are getting 81 point something. Okay, this is what? This is a 39, and when you will do the average of this chlorine and calcium, 35 plus 40, it's 75.5 divided by 2 means 37.5 it is coming. Okay, 37.75. Okay, now lithium, sodium, potassium. So lithium is where? Sodium, sodium, potassium. So lithium, okay, sodium is 23, it will become 39 plus 7. 39 plus 7 is 46 divided by 2 is 23. Okay, both side we are getting 23. Now barium, Sr and Ca. Sr, okay, barium will be the middle, 80. Sorry, Sr will be the middle. Sorry guys, Sr will be the middle. Middle means 88. And then this Ba, 80 plus calcium is 35.5. So 80 plus 35, 80, 90, 115. 115 divided by 2 means you are going to get 50. 2 5 the 10, 115, 57 point something. So which of the following does not form trade? Does not form trade. Calcium, bromine, iodine. Correct answer is this. Which of the following does not form trade? Which does not form trade? Does not form trade means mass of middle element should not equals to the average mass of first and third element. So this is, oh sorry guys, sorry guys. Now see the question is, sorry. See the question is, guys, which of the following does not, no, sorry. Which of the following form trades? Which of the following form trades? The form trades means, guys, we know the atomic mass of middle element is equals to the average of atomic mass of first and third element. When we did here, we got 80. This is 80, but we are getting this chlorine and iodine. When we are adding and dividing by 2, we are getting 81 point something. It is not forming the trades. Here also, guys, 30 is not equal to this. It's not forming the trades. Here also it's not forming the trade, but in this it's forming the trade. 23 equals 23. That's it. Okay, this is not the thing. Okay, so question is, which of the following form trades? Option C is the correct answer. Okay, which of the following set of ions represent the collection of isoelectronic species? Guys, we know isoelectronic species means, yes, iso means same, electronics means which have same number of electrons, Now check it out. K plus, guys, we know plus means what? We have to minus, because plus, when the plus will come, bolo re pyare, when the plus will come, yes, when we are taking out the electron, so the sign will be plus. So that what we have to do? Originally we have to do the minus. See, if it is K2 plus means 2 plus. So guys, see, in the examination many students will do the mistake is 2 plus means, see, potassium. K is potassium. What is the potassium? K means 19. K is what? 19. So they will say 19, oh, plus 2, 21. Nahi re bhaiya, are oh pyare, don't do like this. What does this mean? This means that plus 2 means, yes, 2 2 electrons we had removed. So removing 2 electron means 19 minus 2. It should be 17, not 21. Okay, yes. So like that guys, we have to see. It is 19. 19 minus 1, 18. Okay, this is 18. Chlorine is what? Chlorine is 17. And then minus means what? We have to add the plus 1. It is 18. Mg is what? See, Mg. Mg is 12. From 12 we'll do minus 2 is 10. No, it is not following. Like that we have to check. Sodium. Sodium is, see how much? Sodium is 11. From 11 we have to minus 1. That is 11 minus 1, 10. Now calcium. See, the calcium is where? Calcium is 20. From 20 we will minus 2 is 18. It's not isoelectronic. Iso means all should have a same electron. Isoelectronic species. Now guys, see here. K is what? 19. 19 minus 1, 18. Calcium is what? 20. 20 minus 2, 18. Scandium is what? 21. 21 minus 3 is 18. Calcium is what? 17. 17 plus 1 is 18. All are 18, 18, 18. Yes, option C is the correct answer. Like that you have to do. Isoelectronic species means same number of electron they have. So guys, we know first of all we have to see the, like suppose Sc3 plus. Sc means scandium. So first of all we have to see scandium atomic number is 21. Now guys, plus indicate that we are removing the electron. If removing the electron means this, it will decrease. Minus how many electrons we remove? 3. So that is 18. Like that you have to check. So scandium Sc3 plus is having total number of electron is 18. So like that we have to check. Okay. Electronic configuration of Cu2 plus. Guys, understand one thing. Electronic configuration of copper and chromium, maximum time they are asking, and the chances also that they can ask, because see the electronic configuration of copper and chromium we know, yes, they have exception. Electronic configuration of Cu2 plus. So first of all we will write for Cu. Copper is atomic number is 29. The atomic number 29 means electronic configuration is what? Argon. From argon we will change argon 3d10 4s1. So guys, Cu2 plus, 2 plus means we have to remove the 2 electrons. So 29 minus 2, atomic number 27. So remove the 2 electron means first we will remove the electron from S, then we will move on D. So S means 1 it will remove, it will become 0. From remaining 1 we will remove from D, it will become 9. Okay, because we have to remove 2 electrons. Next, oxide of an element whose electronic configuration is this much. So according to the electronic configuration we can find the atomic number. The electronic configuration 2, 2, 4, 6, 10 plus 1. Atomic number 11. Atomic number 11 is sodium. So guys, sodium is what? Alkali metal. The oxide of an atom, the oxide of an alkali metal is nothing but basic nature. Okay. Now, an element with atomic number 21 is which block? Guys, you know atomic number 21 is nothing but D block. That is called as transition metal. So, a transition element. Now, electronic configuration of C. Previously, they asked electronic configuration of copper Cu2 plus. Now, they are asking electronic configuration of chromium Cr3 plus. So first of all, we'll write for chromium. Chromium is 24. So its electronic configuration is Ar3d5 4s1. Now Cr3 plus. 3 plus means what? We'll remove the 3 electrons. So 24 minus 3, we have a 21 electron. So it will be Ar. 3 electrons we have to remove, guys. Jaldi jaldi dekho bhaiya. So first we'll start from outer. Outer is S. So from S we will remove the 1 electron. Now remaining 2 we will remove from. Next is what? D. So from D we will remove the 5 minus 2 is 3. So we remove total of 3 electrons. So this is the correct electronic configuration for Cr3 plus. Now Mg2 plus is isoelectronic with. Isoelectronic means Mg2 plus is having same electron with which. So Mg means, guys, 12 and plus 2 means 2 will reduce. So Mg2 plus is 10. Now we have to see which is having 10. Copper is, guys, see copper का देखो क्या है. Copper atomic number is 29. 29 will remove 2, that is 27. It's not reaching 10. No. Zinc. See zinc. Zinc is how much? It is 30. 30 we have to remove 2. 30 minus 2 is 28. No. Sodium is 11. From there we have to remove 1. 11 minus 1 is 10. Yeah. Calcium is also guys, भैया calcium बहुत दूर है. See calcium का है, calcium is 20. From 20 we'll remove 218. So this is the answer, C number. Correct order of first ionization enthalpy, guys. First ionization enthalpy, we know the first ionization enthalpy means directly we are removing from, yes, first ionization enthalpy means directly we are removing from the normal element. So guys, how many elements are there? Lithium, 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 boron, 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 beryllium, 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 carbon, 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 carbon. Means we have only four elements. So we'll write the 4 elements electronic configuration. Lithium is what? Atomic number 3. Atomic number 3 means what is that? 1s2 2s1. Beryllium is 4, 1s2 2s2. Boron is 5, 1s2 2s2 2p1. Calcium is 6, 1s2 2s2 2p2. Okay, so guys, we have to find the correct order of first ionization enthalpy, so which is having the highest. Guys, see here, ionization enthalpy, we know the energy required to remove the, yes, energy required to remove an electron. So removing an electron, so it's the first ionization enthalpy, means first we have to remove the electron. Guys, we know removing electron is difficult part. So guys, first of all we will see here which is the very smallest element. The smallest element is what? Smallest element is this lithium. So what is the electronic configuration? 1s2 2s1. Guys, in the 2 we have s1, just we have to remove one electron. So lithium is what? See here guys, see 1s2 is filled, leave it off. When we'll talk about 2, here in 2 we have s with just one electron. If you will see here, in 2 we have s with 2 electrons. In B we have 2 is filled, guys, see 2 is with s and p, we have a 3 electrons. In carbon we have 2 with 2 to 4 electrons. So which will be the least? Lithium will be the least, because removal of electron from lithium is very easy. We have to remove just one electron, that's it. We'll remove the one electron, that's it. So lithium will be very least, because here we have a 2 electrons, here we have a, see 2 right, s and p means 2 plus 1 3 electron, it entered into the p block. Then here again 2 2 right, 2 2, so sp, so 2 plus 2 we have a 4 electrons. So guys, what will happen, where this is very small, s is having just one electron, so we will remove the s electron easily from here. Okay, so what is happening, very easy to remove is lithium. So lithium is very less, so very less is what? Lithium. So either A or D, they have a lithium. Okay, now next we have to see that either boron, beryllium, boron, beryllium, boron, beryllium, which is the easiest to remove. See, in boron we have a 2s2, beryllium we have a 2s2 2p1. To understand, very important, sorry, in beryllium we have 1s2 2s2, in boron we have 1s2 2s2 2p1. So guys, very important thing is in beryllium this is 2s2, means what? S is completely filled, S is completely filled. In boron we can see S is filled, but P is just one filled. So guys, this boron will become easy to remove just one electron of P. So lithium, then boron. Then after that, see the beryllium. Beryllium we have S2S, that is completely filled. So then beryllium. Now next is carbon. Now you can answer why the beryllium is completely filled. So beryllium should be here now. The carbon should be here. No, the reason behind is, understand guys, understand. Lithium, why the lithium is at very lowest? The reason behind is lithium is having just S1. So one element removal is very easy. Now boron is what? P is having just one electron. But beryllium we have a S which is having 2 electron completely filled. So beryllium is having P which is having 1 electron, sorry, boron which is having P which is having 1 electron, and then carbon which is having P but 2 electron. So guys, for the boron, removing this 1 electron for the P is very easy. So after lithium it will be boron. Now beryllium and carbon. So carbon went to P block and beryllium is still in S. So we will first focus on the beryllium. Then we'll go for the carbon. The reason behind is carbon already went to P. Okay, so beryllium is in S. So I see S, this is completely filled. So now beryllium will come and then remaining is carbon, which is went to the P. Because see the carbon, it is 2P. How many P? 2P. So it's already the bigger. So like this, carbon, beryllium, boron, lithium. I hope you understand this. Or if you want to check it out, you can check it out like this also, guys. Very easy thing I will tell you. We have to see the correct order of first ionization enthalpy. So first ionization enthalpy, guys, see this trick I am telling you for the first ionization enthalpy. Maybe in the examination they can ask you for second ionization enthalpy, or maybe in the examination they can ask you for third ionization enthalpy. So see, see, first ionization enthalpy you can easily find with the help of periodic table. So see, first ionization enthalpy means lithium, we have a 4. Lithium, boron, beryllium and carbon. So guys, which we know that what is the, see, this trick I am going to tell you only for first ionization enthalpy, not for the second ionization enthalpy or third ionization enthalpy. For second ionization enthalpy and third ionization enthalpy I will explain you. Okay, see, for first ionization enthalpy what we will do now, directly we will see the periodic table. That's it. What we know for the ionization enthalpy, guys, see what we know for the ionization enthalpy. We know for ionization enthalpy is what? Along the period increases, down the group decreases. Okay, so now check it out. Along the period is increasing, so which is more, guys? See, lithium, where lithium is here, beryllium is here, boron is here, carbon is here. So along the period it's increasing, so which is at highest? Carbon is at highest. So we can see in the option where the carbon is at highest. Here the carbon is at highest, here the carbon is at highest, here the carbon is at highest. Here lithium no value. Now all are same: lithium, beryllium, boron, carbon. So carbon is at highest, so carbon is having more electron negativity. Now we will see the lithium is at the least. So lithium is at the least, where lithium is the least. Here lithium at the least, and here A or D. Okay, now boron and beryllium. Now you will see, guys, this is a beryllium where the S block is done. This is the beryllium where S block is completely filled. So what I said, guys, half filled and completely filled is having more ionization enthalpy or more ionization energy. So then beryllium is more as compared to boron, because boron is just entering into the P block, it is having P1. So that's why beryllium is more than boron, because beryllium is at the end where we have S2, the completion of the S block. Okay, so for the first ionization enthalpy, in place of writing this electronic configuration and doing gibberish things, what we can do for the first ionization enthalpy, guys, just check the periodic table. Okay, sorry, I said electronegativity previous, right? It's ionization enthalpy. Okay, for the first ionization enthalpy, guys, just check it out the periodic table. What you will see, just check it out the periodic table for first ionization enthalpy. From the periodic table you will get to know about the first ionization enthalpy. Okay, the first ionization enthalpy is what we know: ionization enthalpy increases along the period, decreases down the group. So according to that you can see and you can tell that which is the correct ionization enthalpy. Only for first ionization enthalpy we will see the periodic table. Like, see, beryllium and boron was getting the confused. So you will see here beryllium is present at the end of the S block, which is S2. So beryllium will having the more what? Ionization enthalpy. And then this boron is just entering into the P block, it's P1. So removing of one electron is easy. So next is what? Next, boron. The boron is less, beryllium is more than carbon for the ionization enthalpy, because we know what do you mean by ionization enthalpy. See, ionization enthalpy means energy required to remove an electron from the outermost shell. So if it is the first ionization enthalpy, guys, we will check it out from Yes, periodic table. Okay, but suppose if it is a second ionization enthalpy or third ionization enthalpy, then we have to write its electronic configuration, and from here we will get to know. So first ionization enthalpy means, see, for lithium what will happen, it will become 1s2 because I remove this one electron. Okay, after first ionization enthalpy, lithium is this 1s2. After first ionization enthalpy, beryllium is 1s2, I remove one electron, that is 2s1. After first ionization enthalpy, boron is 1s2, 2s2, I remove this one electron. After first ionization enthalpy, carbon is 1s2, 2s2 to p1. Now for finding the second ionization enthalpy, in the first ionization enthalpy we get to know this. Second ionization enthalpy, guys, which is the difficult? See here, S2, S is completely filled. Here S is 1. Here S is completely filled. Here this. So what we will see? We will see 1s2, 2s2. So this 2 is completely filled. So higher will become boron. Why? The reason behind is boron will break from here and boron will reach it here. So this is what, guys, it's completion of the S block. Completion of the S block. So that's why boron. Then after that 1s2, this lithium. Lithium is where, guys? Lithium is here. It will break, means it will lose one electron and it will reach it to here, noble gas, which is what? Bolo re bhaiya. Yes, which is more stable. So it will become noble gas. It will become noble gas means it is becoming helium. Lithium lose one electron, it become helium. Boron will lose one electron, it will become, what is becoming? Beryllium. Beryllium. Okay. Now what is this? Be. This is the beryllium. It lose one electron and it's become at 1 2 plus 1 3. 3 atomic number 3 means lithium. Right, hydrogen, helium, lithium. Now carbon. Carbon atomic number was 6. It removed one electron, means it lose one electron and it will reach to 5. 5 means what? Boron. Understand? Now from here we will see again same thing, guys. Helium will be more because it is at the along the period, at the end, helium. Then after that helium, what is that? Lithium, beryllium, boron. So after helium, lithium, beryllium, boron. So beryllium will be the more, then boron, then lithium. Correct? So guys, what will happen? For the first ionization enthalpy, just we will see the atomic number and just we will see that where it is present in the periodic table. Along the period, high ionization enthalpy, down the group, low ionization enthalpy. Okay, and ionization enthalpy, if we'll go along the period and down the group also, we will see that if its orbital is half filled or completely filled, it is having more ionization enthalpy. Okay, according to that you will get to know the first. From first, what we will do, guys? From first we have to remove again one electron and it will become second ionization enthalpy. For second ionization enthalpy, what we will do? Again we will write like this in the form, and then you will see that lithium remove one, means lithium lose one electron and it's become atomic number 2. Atomic number 2 means lithium become helium. So atomic number 2 is where? Here, helium. Means at the end of the period, means it is the highest ionization enthalpy. So like that you have to again rearrange it. Understand? Yes, sir. Okay, now properties of halogen which is not correctly matched. So guys, this density is correct, guys. Density first. Density means what? Think, denser. So iodine is more, then bromine, then chlorine, then fluorine. Bigger size, dense. Iodine is more, bromine, chlorine, fluorine. This is the correct matched. Now ionization enthalpy, fluorine is more, then chlorine, then bromine, then iodine. Okay, because we know ionization enthalpy means what? If you will go down the group, it decreases. The fluorine is more, then chlorine, then bromine, then iodine. This is correct. Electronegativity also follows, guys. I see here. Okay, see electronegativity. चलो देख लो यहाँ पर क्या होता है electronegativity, guys. See electronegativity, if you go down the group, it decreases. Okay, so see here, the fluorine is more, then chlorine, then bromine, then iodine. So this is also correct, which is wrong. This EGE means electron gain enthalpy. This is wrong order. Guys, electron gain enthalpy, we have an exception. Fluorine, chlorine, bromine, iodine, if you will take, exception is this. Fluorine and chlorine will interchange. The chlorine, fluorine, bromine, iodine. The reason is what? Guys, see, in this chapter, reason is due to, yes, shielding effect. Poor shielding effect. Okay. Amphoteric oxide among the following, guys, we know amphoteric oxide is BeO, Al2O3. These are the amphoteric oxide. Third ionization enthalpy is highest in, guys, third ionization enthalpy. Third ionization enthalpy means from neutral atom we have to remove one electron. This is the first ionization enthalpy. Again we have to remove one more electron. Second ionization enthalpy, again we have to remove one more electron. Third ionization enthalpy means we have to remove 1, 2, 3 electrons. So this removing one electron from here, first ionization enthalpy, from here removing second, from here removing third. So we have to see alkali metal. Alkali metal means this is the alkali metal. From alkali metal, if you remove one electron, that is the first ionization enthalpy, you will reach it here. Second ionization enthalpy, you will reach it here. So for third ionization enthalpy, it will be easily removed because you are at P5. This is what? This is the P5. So easily remove P4. Okay, so this is not that much. Now alkaline earth metal. Alkaline earth metal is this. If you will remove one electron, means first ionization enthalpy it will reach here. Second ionization enthalpy it will reach here. Noble gas. So for third ionization enthalpy it will be very high because noble gas is having the highest ionization enthalpy. Very difficult to remove electron. So third ionization enthalpy is more for alkaline earth metal because see chalcogen and nitrogens. So chalcogen means group 16. Group 16 is this chalcogen. Okay. So if you will remove the one electron, means first ionization enthalpy it will reach here. Second ionization enthalpy it will reach here, means P2. So third ionization enthalpy it will easy to remove from P2 to P1 because half filled and completely filled is difficult to remove. So alkaline earth metal, if you will remove one electron, first ionization enthalpy it will reach here. Second ionization enthalpy it will reach here. Correct? It will lose the electrons, it will reach here. So here if it will reach for the second ionization enthalpy, so what we have to find? We have to find for third ionization enthalpy. Third ionization enthalpy means from here we have to remove electron. So this is completely filled. So completely filled or half filled means bolo re pyare. Yes, they have a higher ionization enthalpy. So our correct answer is alkaline earth metal. First ionization enthalpy are in order. So okay, first ionization enthalpy are in order means directly we'll see from periodic table. The first is carbon, nitrogen, silicon, phosphorus. The phosphorus is more. Carbon, nitrogen, silicon, phosphorus. No guys, phosphorus is not more because carbon, nitrogen, silicon, phosphorus. Nitrogen should be more. Then carbon, right? Then phosphorus, then silicon. So we have only 4 elements: carbon, nitrogen, silicon and phosphorus. Yeah, carbon, nitrogen, silicon, phosphorus, carbon, nitrogen, silicon, phosphorus. Yeah, so what will happen guys? First will be nitrogen because along the period, then carbon, then down the group will come here. So again along the period is phosphorus, then silicon. So carbon, nitrogen, phosphorus, silicon. Nitrogen, carbon, phosphorus, silicon. Okay. Now next, which of the following is the correct order of radius? Correct order of radius. Guys, correct order of radius means first we will see the atomic number only. Whose atomic number is radius is less, whose atomic number is more, whose radius is more. Correct? Atomic number is more means what will happen? The size will increase. If size will increase means radius will increase. Khatam. So we'll see. See from here, aluminium Al3 plus. What is aluminium? Aluminium is 13. From 13 we will remove 3, its atomic number 10. Mg2 plus, Mg is 12. From that we will remove the 2, it's 10. So both atomic number is 10. So correct radius should be equal, right? It is given like this. So this is D is not possible. Fluorine is what guys? See, fluorine is 9. From 9 we will add 1, it will become 10. Oxygen is what guys? Oxygen is 8. From 8 we will add 2, it will become 10. So again the atomic number is same. If atomic number is same means atomic radius will be same. It should be equal, but they're given greater, it is wrong. So same like that you have to see. See here, hydrogen minus, hydrogen is 1, 1 minus 1, 2. This is what, 1, and this is what, 1 minus 1 is 0. So yes, 2 is greater than 1 is greater than 0. So this is the correct answer. That's it. Next, which one of the following metallic oxide exhibit amphoteric nature? Guys, amphoteric oxide, I said Al2O3 is the amphoteric oxide. So guys, what you have to do, just go to the Google and just type 10, not 10, 5 amphoteric, like you can just write on this name. Give a 5 example of metal oxide which shows amphoteric oxide. That's it. And remember the name because in the examination continuously they are asking. Okay. Now electronegativity of carbon, nitrogen, silicon, phosphorus. Oh, same questions. Electronegativity of carbon, nitrogen, silicon, phosphorus. So guys, electronegativity. So what will happen for the electronegativity? Arey oh pyare, dekho na re bhaiya. See, electronegativity means increases along the period, decreases down the group. It's same like ionization enthalpy. So we have to follow the same thing. Along the period is increasing. Along the period is increasing means nitrogen is more than carbon, and down the group it's decreasing. So down the group means silicon and phosphorus. So in this group, what this? Along the period, phosphorus is more than silicon is more. So nitrogen greater than carbon, greater than phosphorus, greater than silicon. So see, nitrogen greater than carbon, greater than phosphorus, greater than silicon. Okay. Guys, this is important. This is very important. I say, for one of the element, various, sorry, not this. See, for one of the element, any element they have taken, let us suppose element is X, not yours. So for one of the element, any element we have taken, for one of the element, various successive ionic, this is ionization enthalpy are given below. Okay. Now guys, understand one thing. They will give you for one of the element, any element they will take, and with that element they will give the successive ionization enthalpy. Very important concept, guys. See, they will take any one element, and for that element they will give the successive ionization enthalpy like this. First ionization enthalpy value is this much, second ionization enthalpy value is this much, third ionization enthalpy value is this much, fourth ionization enthalpy value is this much, fifth ionization enthalpy value is this much. Whose? For one of the element. So in the question, in the examination, for any one of the element, they will give the various successive ionization enthalpy. So these are the successive ionization enthalpy they had given for any one of the element. Now you have to find which element is this. Okay guys, what type of question they will ask? They will say you that for one of the element, means for any element they will give the successive ionization enthalpy like this. In that you have to find which element is this. Guys, very easy trick I am telling you. Just check it out, from which value of ionization enthalpy there is a higher jump. From which value of ionization enthalpy there is a higher jump. Chalo re pyare, dekho re bhaiya. From here guys, it 577 to 1800 means it is a jump of around 1300. Here 1800 to 2700, around jump of 900. 2700 to 11,000, jump of 9,000. So 9,000. Again 11,000 to 14,000, jump of 3,000. So where is the highest jump, guys? Highest jump you will say, sir, after third. After third we have a highest jump. So guys, first thing what we have to see, that in successive ionization enthalpy where is the highest jump. So you see, this is the highest jump of 9,000 value, means after third ionization enthalpy there is a highest jump. So where is the highest jump, we will take that. So after third ionization enthalpy there is a highest jump, so we will not take for fourth. After which? After third there is a highest jump. So third means what, guys? whatever this value will come, that value we will say that it's valence electron. So whatever the element is there, it has 3 valence electron. So suppose if it is jumping from second, means element has 2 valence electron. If suppose it is jumping from fourth, means element has 4 valence electron. So from where it is jumping, the element has that much valence electron. So it is jumping from 3, so element has 3 valence electron. Now check it out, which element is having 3 valence electron. Guys, we know aluminium is having +3, because see, phosphorus is where the phosphorus is present. Phosphorus is present here, its valence electron is 3. Bolo. So whose valence electron is 3? That is the correct answer. Al3 plus, we know. Phosphorus, guys, see, phosphorus, what will happen? We know electronic configuration is ending at noble gas. Electronic configuration is ending at noble gas, again starting from S1. So phosphorus means it ended here, it started from here. So 1, 2, 3, 4, 5 valence electron. It has 5 valence electron, so not possible. We want 3. Now magnesium. Magnesium means it is ending here, again it starts from here. So 1, 2, Mg2 plus, no. Silicon. Silicon is where? Silicon is here, guys. We know electronic configuration end up at every noble gas. So again start from S1 here. So silicon means 1, 2, 3, 4. 4 valence electron, not possible. Aluminium is having 3 valence electron. So correct answer is aluminium. See, aluminium is where? Here. So 1, 2, 3. 3 valence electron. Ashte, guys. Ashte. Now correct order of electronegativity. You have to see the electronegativity order for this. This is your homework, guys. Just check it out whether you are getting this answer or not. Okay. Now next. Order of stability of metal oxide. Very important, guys. Another important. You have to find the order of stability of metal oxide. To understand one thing very important. Lattice energy formula is what? Lattice energy is directly proportional to charge by size. Means if size will increase, lattice energy will decrease. And lattice energy is directly proportional to stability. Guys, see, we have to find the order of stability. The order of stability is directly proportional to lattice energy. Means lattice energy increase, stability increase. Lattice energy decrease, stability decrease. Okay, so stability depends upon what? Stability directly proportional to lattice energy. If lattice energy is increasing, stability is increasing. Okay, so stability directly proportional to lattice energy. So we'll see the formula of lattice energy is what? Directly proportional to charge by size. Means lattice energy is directly proportional to charge, lattice energy is inversely proportional to size. Okay, whose size is bigger, it's having less lattice energy. So just check it out like that only, guys. Okay, so see, oxygen we will not see. These elements are changing. So Fe, guys, here they are saying that stability is more for Fe. Means Fe is having higher lattice energy. For higher lattice energy means Fe size should be less. So guys, Fe, aluminium, magnesium, Fe is here 26, aluminium is 13, magnesium and chromium. Magnesium is where? Magnesium is 12, chromium is 24. So guys, see, Fe is having highest size. So if size is more, its lattice energy is less. If lattice energy is less, means stability should be less. So Fe stability should be less. So that's not possible. Now here you can see Fe stability is less. Then chromium, aluminium, manganese. Chromium, guys, see, Fe 26, chromium 24, aluminium 13, manganese 12. Correct. So chromium size is less. Sorry, chromium size is more. The lattice energy is less. Then chromium, then aluminium, then magnesium. Okay. If size is more, lattice energy is less. If lattice energy is less, means stability is also less. So Fe size is more, lattice energy is less. Lattice energy is less means stability is also less. Then chromium, then aluminium, then manganese. Manganese, Mg means, guys, see, Mg is 12. 12 means what? Mg size is very less. If size is less, it have a more lattice energy. More lattice energy means more stability. So Mg is having more stability. Okay. Chromium and aluminium. See, chromium is 24, aluminium is 13. So obviously chromium is having more size. More size means less lattice energy, less stability. So chromium is less stability. Aluminium is smaller size, high lattice energy, high stability. So this is the correct answer. Okay. Now correct order of ionization in energy, guys. Again you can check it out, the ionization energy for copper, nitrogen, oxygen and fluorine. That's it. Okay, in the periodic table, metal usually used as catalyst belong to D block. Important question, guys. And this is also important question, guys. This type of question they will ask in the examination. Very important, guys. Very important. And very easy also. See, an atom of element A has 3 electron in its outermost orbit. The element is having how many valence electron? 3 valence electron. Correct? Because they said element A has 3 electrons in outermost orbit. Outermost orbit means valence electron. So A is having 3 valence electron. And that of B has 6 electron in its outermost orbit. So 6 electron in its outermost orbit means 6 valence electron. So B is having 6 valence electron. Okay. The formula of the compound between these two, A and B. Guys, see, very important thing. Valence electron, for making the formula we have to write it here, correct? And then we have to interchange, we will get the formula. Easy peasy. So for writing here, guys, we have to write, we are not going to write the valence electron. In the examination the student do the mistake, the same thing. They will write the valence electron here. No. Here we will write the valency. And we know valence electron and valency are different. So A is having 3 valence electron. So 3 valency. B is having 6 valence electron to 2 valency. Okay. So what will happen? 3 valence electron, 3 valency. Guys, see, because we know 1 valence electron, 1 valency. 2 valence electron, 2 valency. 3 valence electron, 3 valency. 4 valence electron, 4 valency. After that it will become ulta. 5 valence electron, 3 valency. 6 valence electron, 2 valency. 7 valence electron, 1 valency. 8 valence electron, 0 valency. And here also 0 valence electron, 0 valency. Okay, like that. So 3 valence electron, 3 valency. So A has 3 valency. B has 6 valence electron to 2 valency. Why it's happened like that? Because total we want 8 electron. Here 6 plus 2 8, 5 plus 3 8, 4 plus 4 8, 7 plus 8, 1 8 plus 0 8. Okay, and here it will be like 0. 3 minus 3 0, 2 minus 2 0, 1 minus 1 0, 0 minus 0 0. Like that. So A is having 3 valence electron. Wait, so valency is also 3. So we'll write this 3. B is having 6 valence electron to valency is 2. Then we'll interchange. So it will become A2 B3. This is the formula of the compound. And guys, yes, this is the done. This is the end. Hold your breath. 50. Okay, 1 hour 20 minutes. This video is done. See. So that's why I made it in a one only. I completed this thermodynamics. I'm saying this classification of elements and periodicity in property. I completed in one video only. It's not the part A, part 1, part 2. Okay, guys. So keep on doing the revision. If you have any doubt, guys, please feel free to do comment in the comment section. That doubt I will explain you in the next video, and then I will continue the another video. Okay, so don't hesitate to ask the doubt, like, oh, others are not asking the doubt, I will ask the doubt. So what the others will think, what the teacher will think, that oh, he or she don't know the things. No bhaiya, you are doing for yourself. No one is here to support you. You are doing for yourself, to do it for yourself. Don't see here there. Okay, so that's done, guys. So, and if you like it, please like the video, share the video to your friend. Okay, and subscribe the channel, guys. Okay, guys, thank you. Bye bye. We'll meet in the next video.